Okay, so we left off having derived this formula from just a geometrical analysis using the distance formula. So first thing we're going to do is derive the sum formula, cosine alpha plus beta. And so all that has to happen here is our second angle gets turned into minus beta. And this is a good opportunity to review our even odd properties of cosine and sine. So for cosine, the negative gets eaten up. Cosine alpha, cosine beta. And for sine, it pops out. So this minus pops out front. So we got negative sine alpha, sine beta. So this is very similar. All right, so the next step is looking at the half angle theorem, which we've already kind of looked at by virtue of just thinking about right angle trigonometry and the significance, and we'll connect it back to that in a second. So I can use this. This is my alpha, this is my beta. So then cosine pi halves cosine theta plus sine pi halves sine theta, right? We're going back up to this formula here because this is a difference. Cosine of pi halves, let's just draw a quick unit circle. Pi halves is up here. We got 0, 1. So this is going to be 0. This is going to be 1. So this term goes away. So this is equal to sine theta. So what I was saying about the right triangle trigonometry is that that connection is really just another way of saying, well, if we have a triangle and we've got an angle down here, theta, this angle is pi halves minus theta, or in other words, 90 degrees minus theta, because 90 degrees of the 180 degrees is taken up. So these two have to add up to 90 degrees. So then in other words, when I'm saying cosine of this angle, that's adjacent hypotenuse. Well, that's exactly the same as the sine of this angle because that's adjacent over hypotenuse. So that's the relevance of that. So now we're going to do a little bit of trickery here. Let's see if we can derive sine sum or difference. So first of all, let's start with turning this around. If I want to know the sine of theta or the sine of alpha, let's say minus beta, then I can think about that as the cosine of pi halves minus alpha minus beta. Okay, so now we're going to do a little bit of trickery here by rewriting that as cosine pi halves minus alpha plus beta. Okay, so we just kind of distributed the negative. We're grouping this together. This is the plus version. So here we are. I'm going to circle the cosine sum here. Okay, so now we just need to apply it. The first angle is this one, and the second angle is this one. So it'll be cosine pi halves minus alpha cosine beta minus sine pi halves minus alpha sine beta. And now we're going to make a switch And I proved one of these, I didn't prove the other one, but it's the same concept. Think about it in terms of trigonometry. If we're standing in one corner of the triangle, sine of pi halves minus alpha is the same as cosine alpha. So this is where we get our simplified version. Sine alpha, cosine beta, minus cosine alpha, sine beta. This is sine alpha minus beta. And similarly, we can do the plus version, alpha minus beta equals sine alpha cosine minus beta minus cosine alpha sine minus beta. Again, apply the even and odd formulas, and you end up with sine alpha plus beta equals sine alpha cosine beta minus cosine alpha, and the minus comes out, plus sine beta. Okay, so you got yourself the 4 versions, and what I provide for you in the formula sheet will be only the positive versions, this one and this one. And then from the rest can be derived. If you start with these, you can derive these. You can derive the minus ones by just sticking in negative beta here or here. You know, the half angle theorem you can prove using these. And the double angle can be derived, and that's actually where we're headed next, is to do the double angle for cosine and sine. So let's pause there, and we'll do the next part in another video.